Um, so I'm Erin Hare. I'm a founding member of AppSciComm. We are a group founded in early 2019 that seeks to provide science communication support and camaraderie in a traditionally underserved part of the country, Appalachia. We welcome science communicators of all stripes. That's practicing journalists, institutional writers, freelancers, talkative scientists, students, podcasters, really anybody who wants to join and has an interest is welcome. We're a social and professional network. We host regular events, and as the pandemic seems to be winding down, we hope to start doing more of those in person. But the pandemic has given us the opportunity to, I think, engage with our geographically spread out group to make it a little bit more accessible to folks who aren't necessarily based in Pittsburgh, like me. And so we welcome you to join our Facebook group. You could also follow us on Twitter and check out our website if you haven't already, and invite your friends. We got one more person in the waiting room. Okay, so without further ado, we'll get to today's event, which will be moderated by the inimitable Mark Roth, who is a longtime science reporter at the Pittsburgh Post-Gazette and is currently enjoying his retirement by working as a freelancer. And Mark will facilitate this discussion between Lyle Chamberlain and John Thornton. Lyle is the CTO and co-founder of Near Earth Autonomy. He has over 2 decades of experience in field robotics implementation and testing, with the majority of his work involving aircraft. Lyle has led technical development and deployment of autonomous aircraft ranging in size from helicopters that carry 5,000 pounds down to vehicles with a payload of just 5 pounds. He's now focusing on safety assurance for autonomous aircraft to allow widespread adoption of flying, delivery, and passenger vehicles. Lyle graduated from Caltech in 2005 with a BS in engineering and applied science, and worked for 8 years as engineering staff at Carnegie Mellon Field Robotics Center before starting Near Earth Autonomy with 3 other members. John Thornton is the CEO of Astrobotic. He has grown Astrobotic's business of delivering affordable space robotics technology and planetary missions by attracting technology contracts, equity investment, and payload customers. Under his leadership, the company has booked 3 lunar missions with its Peregrine, Griffin, and MoonRanger spacecraft. At Carnegie Mellon University, John led the build of Scarab, a NASA concept rover for lunar drilling, and the first rover to carry a prototype of the NASA Resolve payload that will now be flying to the lunar South Pole on the NASA Viper rover aboard Astrobotic's Griffin lander. John also founded the Carnegie Mellon University Advanced Composites Lab, a research training, design, and manufacturing program specializing in high performance, lightweight composites for robotics. And now I will kick it over to Mark to lead this panel discussion. Thank you both, Lyle and John, for joining us today.
Thank you. After listening to those bios, I think, how in the world can we compress all that expertise and knowledge into an hour's discussion, but we'll do our best. I think the easiest way to start out, I know that you both share a background in robotics and, autonomy software, but I think the easiest way to start would, have each of you describe sort of the central missions of your companies and the projects you're currently working on, if you could summarize those. So John, would you like to kick it off?
Sure thing. Very nice to be here, and thanks for having me. Astrobotic's all about building a affordable, regular, routine delivery service to the surface of the moon. So our first mission flies next year. Our second mission flies in 2023. And at the core, we're essentially like a delivery truck taking payloads, our customers from all over the world. We bolt them on our lander, fly them up to the surface of the moon. And once we get there, we provide power and communications for the customers that come with us. So we become that power and communication station. So the company is, we're over here in the north side. We've got 47,000 square feet building under roof here, 145 employees and counting. And we are part of NASA's return to the moon with the Artemis program. So we're the tip of the spear of NASA's return to the moon with robotic precursor missions. And NASA has plans with the Artemis program to put the first woman astronaut on the surface of the moon inside of this decade.
Great, thanks very much. Lyle?
Mine doesn't sound as flashy as yours, John, but the difference might be that we're using similar technology, but the people that are listening right now might end up getting something delivered to them by our technology, or they might actually be flown with our technology sometime in the future. So there's kind of a revolution going on right now in moving people and packages. You've seen the drones that are everywhere that people fly around, and you've seen helicopters flying, and what's happening is those two areas are starting to merge together, and we're starting to see the advances in battery technology and motors and computing are making smaller vehicles that could carry 400 pounds, 500 pounds and do deliveries over medium or moderate distances a reality, and it's set to really change the way logistics are done, both commercially and also in the military. So we are involved in making these aircraft safe and reliable, and we're using the autonomy technology that you'd see if you live in Pittsburgh. You probably see robot taxis driving around all the time. I think there's 6 companies now working on autonomous vehicles, and in Pittsburgh, and they all came from the same place John and I came out of, Field Robotics Center. And the people that formed Near Earth, we left and started a company as well, but we took all of that self-driving car tech and started applying it to self-flying vehicles. So what we do is we have all these different technologies that enable an aircraft to operate, to fly itself without having an aviator on board or even necessarily having an operator there. So our systems are there when things go wrong, when you lose communications. The aircraft needs to do the right thing. It needs to respond to emergencies by itself. It needs to handle simple contingencies. Say somebody accidentally left a suitcase on a landing pad. It needs to have some common sense that don't land on that, just move over and land to the side, right? Or if the trees have grown in an area since the last time somebody flew there, the vehicle will see those trees and respond appropriately, avoid them. So there's a bevy of different capabilities like that, and Near Earth provides those. We've been around for 8 years, and I think we just crossed to 90 employees last week. So we're going strong, and we have a lot of partners, that some of whom we've announced publicly that we're helping them create logistics chains and delivery services with drones that carry a moderate amount of weight.
Great. I do want to dive into each of your projects in a little more detail, but before I do, and I hope this doesn't sound like too parochial a question, but some people hearing about your company's missions might wonder why you're not located in Silicon Valley or in the Houston area for space exploration. And but a lot of us in this group know about the kind of the foundational robotics work that's been done at Carnegie Mellon. I guess my question for both of you is, why did you stick close to home? Why are your companies located here? John, and then Lyle.
Yeah, the biggest for us is the robotics community here in town. So Pittsburgh has one of the best robotics hubs in the country and in the world. And at the core of Astrobotic, we are a space robotics company. So what we do is we think of home growing that robotics talent, and we import space from all over the country, mix the two together, and you get the best space robotics in the world. So that's why we are here. And it's also because we like the city. It's just a good place to live and work and play. So it's just great quality of life, and that's where we chose to be. So we're very happy to be here.
All right, Lyle.
Yeah, I'd echo what John says. I really like living 10 minutes from downtown and an affordable house, and not having to deal with traffic. So it is a very livable place. But what we get here is a network of roboticists. as John said. And we do a lot of work with the military. So we're located very close to DC on one side, and then we can get to hubs to, if we need to go out west, it's not too bad getting out of Pittsburgh. The other piece is we get a lot more bang for our buck here. So we have a nice facility. It's fairly inexpensive compared to what that might cost. We maintain an airport nearby where we can do our flying. We work with the local helicopter company and do leases, things that would be very difficult to do or very expensive in other places. And because the cost of living is lower, also we don't have to pay Silicon Valley wages, right, which are highly inflated compared to the rest of the world.
That all makes sense, and that's really fascinating to know. John, I thought I would ask you to dive in a little more detail into this your first upcoming lunar mission, and also because of some work I've done writing for NASA, I became aware of the fact that this is also sort of a template for the new world of space exploration that involves both government and private entities. So if you could kind of talk about, the rockets that would be used and how your lander interrelates and how NASA is connected, that would be helpful too.
Sure. So to start out, we are part of a program that NASA is running called CLPS. It's Commercial Lunar Payload Services Program. And what that does is it's a new paradigm for NASA. Instead of going off and spending maybe $1 billion on a mission that cannot fail, they're spending on order of $100 million on commercially led missions to fly science to the surface of the moon for regular routine operations. So it's more of a shots on goal approach as they describe it, NASA does. But to get a sense of scale here, they've spent less than $1 billion and they already have 6 lunar missions on manifest. And for NASA, that's incredible value. Even if only half of them succeed, that is still incredible value for the taxpayer. So it's a whole new paradigm. So right now we are one of 4 companies that are on contract in the CLPS program. We have 2 missions, as does one other group. They also have 2 missions. Our first mission flies next year, flies on a United Launch Alliance Vulcan launch vehicle. So this is the upgraded Atlas V launch vehicle. They changed the name for whatever reason, but it's pretty much an upgraded Atlas V. And then our second mission flies on a SpaceX Falcon 9 Heavy. So it's a much larger vehicle on the second mission. So what we do, we build the lander. We build the spacecraft that goes on top of the launch vehicle. So what we do here in Pittsburgh, we build that lander up, integrate the propulsion, integrate our customers, i.e. the payloads onto that lander, and then we ship all of that down to Florida, put it on top of a launch vehicle, and that's on order of 200-foot tall launch vehicle that shoots it to space. And then when the launch vehicle lets go, our spacecraft takes over. So when our job starts, when the launch vehicle throws us towards the moon, and we do small trajectory correction maneuvers on the way out. We slow down into lunar orbit when we get out to the moon, and then we orbit there for just long enough to line up our landing site, and then we fire our engines again, slow down, and come down with a nice soft landing down on the surface. And along the way, we're using somewhat similar technologies to Lyle's company for our landing descent. Our first one will use a optical means for navigation system, a terrain relative navigation. So we're basically looking at features down on the ground and matching them with onboard maps to figure out where we are on the terrain, because there's no GPS on the moon. So we set down on the moon within a few hundred meters of our landing selected site. And then that's when our surface operations begin. So we've got rovers that will drop and drive off. We've got one rover on our first mission that's really cool. It's actually a walking robot that's going to try to walk across the surface of the moon. And then we will have beamed back communications from the surface of the moon and be operating mission control right here from our headquarters in the north side. We have mission control here that's going to be controlling all the spacecraft, and we'll be able to network out to all the different mission controls around the world and send their data back to their respective locations.
Wow.
So all in all, it's Pittsburgh is leading the way for commercial return to the moon.
Yeah, that's very exciting. I didn't know about the walking robot. I think on that first mission, don't you also have that kind of economy rover that the Carnegie Mellon developed? Can you talk about that a little?
That's right. Carnegie Mellon is going to have the first university rover to land on the surface of the moon and operate across the surface. It's a rover called Iris, and it's a small rover about the size of a bread box or a toaster oven. That's got 4 wheels to drive across the surface of the moon, and it's primarily built by students, but it could be the first university robot to drive across the moon. And that's along with a whole bunch of other payloads. We have about 10 NASA payloads, about 6 or 8 commercial payloads on the first mission, and not all of them are active. Some are time capsules, for example. We've got for example, we have the country of Nepal is sending a piece of Everest to the surface of the moon. There was an astronaut that brought a moon rock to the peak of Everest, and now Nepal wants to send a piece of Everest back to the moon. And then we also partnered with local area schools around Mount Everest to bring their artwork and stories and messages to the moon. We've got a company in Japan, for example, it's a soft drink company, but they've created a time capsule with hundreds of thousands of dreams of children from Asia. And then we've also partnered with local schools here in Pittsburgh to send things up. So there's South Fayette has a large time capsule that they're sending, where every kid in the school got to contribute something to that time capsule to be sent up. We even did a competition with the Heinz History Center on what does Pittsburgh want to send to the surface of the moon. And there were all kinds of entries, like the terrible towel, of course, and songs to Mr. Rogers' Neighborhood. And I think it was a sandwich from Permanis. I'm not sure how that would have worked. But the one that won was a token from Kennywood. So Pittsburgh is well represented on this mission.
Great. And just briefly, the walking robot, whose is that?
So that is a company from the UK called SpaceBit. And they're going to be, it's almost like a CubeSat with legs. So it's a very small walking rover, and it's purely technology demonstration to see if they can do it.
Great. Lyle, what I thought I would ask you to do is talk about 2 things. You mentioned in your opening both drones and helicopters. I think most people are pretty familiar with drones and various uses for them, but I think the helicopter piece would be new to many people. So if you could elaborate a little on that work. And then I have a second question as a follow-up, but let's start with the helicopters.
Sure. Well, actually, we started out with helicopters, which might distinguish us a little bit from some of our competition, even that came from the drone world over. We did some work at the university with putting what we call autonomy technology onto different helicopters. And one we did at Boeing with an aircraft they called the Unmanned Little Bird. And that was the first fully autonomous full-scale helicopter that flew. It was an MD-530. And we had demonstrated that. And we actually had, for the first part of that program, I had may or may not have broken into one of the labs at Carnegie Mellon and took a laser scanner from the red team's from the DARPA Grand Challenge, where they were racing across the desert, and one of those vehicles had flipped over and smashed its laser scanner that allows it to see the terrain. But it still kind of worked. It made funny noises, but it still worked. And we used that and flew it on a local helicopter here, the Stat Medevac EC-135, and flew it around and showed that we could do evaluation of landing zones. That followed onto the work at Boeing. And then finally, there was a very large Department of Defense program. And we spun out of the university to address that. And by the end of that program, we were flying an unmanned Huey, a UH-1. So that's a helicopter you might see in a lot of Vietnam movies, but it was completely flying itself. So going to an austere environment, somebody could call in for different supplies and the aircraft comes in and lands itself. So we kind of started there as the art of the possible with the full scale, like it's really hard to build an aircraft, an airframe. So why not start with one that's already been shown to work and then start doing some different delivery missions and use cases with it, with a known aircraft that works well. The other thing that gives us is we can have a safety pilot on board. So he or she can sit there and observe as if this is kind of a student pilot making its own decisions. And if there's an issue, they can intervene. And what that allows us to do is keep our op tempo of testing up really high, similar to what they do with the self-driving cars in Pittsburgh. You see them testing all over the place. You can imagine what would happen if they had to send those out with no person inside. You'd never get to test, right? So that's where we started. We still do fly our full-scale helicopters. We fly one out of, we have a hangar here in Pittsburgh. And, but now we're kind of transitioning that to some smaller vehicles. They're still substantial, but maybe a 12-foot or 6-foot sized aircraft. But their main job is to move things from place to place. And that's where we really focus.
And if what if you've got sort of an economy-sized helicopter and you're doing unmanned delivery of anything, any kind of cargo, what advantage does that give you over a regular drone? What's the advantage of that?
I think that's mainly how we got started. And at this point, what I'd say a modality or an aircraft style, what people might think of as a drone with the big electric motors, like a quadrotor sort of a thing. That technology is advanced to the point that it's a very simple aircraft compared to a helicopter. Helicopters are very expensive to operate. They have a lot of moving parts. You have to do maintenance every certain amount of time, and that's prorated on the cost of operation. So you're talking several $1,000s an hour to operate a helicopter. Whereas you could be much less expensive with just 4 fixed motors and a battery, right? It sounds simple, but there's a lot of work to be done. The idea is that these could be operated with very little infrastructure compared to what a typical helicopter or other aircraft would require. So the military is very interested in it because they could, for example, they want to spread out their distribution channels to do all their logistics. The doctrine ever since World War II has been take the beach and then build a giant stockpile and start doing that. Now in the world of cruise missiles and other weapons like that, a stockpile is not going to work. It would be very vulnerable. And they want to spread this distribution channel or chain out, similar to how Amazon does. And they'll need these aircraft to hop between the points and keep all of the logistics.
Really interesting. I do have another thing to ask you about, but first we have a question from Allison. You want to pop in and ask your question, Allison?
Yeah, sure. And I can ask later too. But as I was listening to you describe kind of the origins of your companies, I was wondering about the origin of both of you, your interest in science, in robotics, before Carnegie Mellon, as grade school students. What got you here?
Do you want to go, John?
It's a good question. It's a good question, and something that's common for a lot of space folks is that there's a spark, there's a moment in time when you kind of catch the bug, and it's that inspiration moment. So Apollo was that for an entire generation of space people, and also non-space people, but just people who wanted to go into a technical career. For me, it was when the Mars lander landed for the first time and deployed that Pathfinder rover. And drove a few tens of feet on the surface of the moon. I was in middle school, and my teacher gave me a project to build a Lego model of it, and I think that's when the seed was planted. And then my parents got me a telescope, and when I got to Carnegie Mellon, I was planning on being a product designer. But then I ran into Red Whittaker and the Field Robotics Center there, and that's when the dream of the moon started. It just kind of woke something up that had been growing inside me for all that time, and I didn't realize it. So when I saw it, I knew it, and jumped on board at the opportunity to take my moonshot.
Great. Lyle?
I wanted to build robots for basically as long as I can remember. I don't know why. So I was really, really into robotics as a kid. I grew up in a town with about 500 people on the edge of the West Desert in Utah. My dad worked at a power plant out there, and this was, well before the internet so the public library was a thing, and ordering books with the interlibrary loan was a thing. So Aaron, you talk about the small towns in Appalachia. I was the small town on the edge of the desert, so maybe a similar scenario. But I ended up getting into the science fairs and building robots. And my junior year in high school, I took second place at the International Science Fair. And that kind of launched me into having connections to places that I could start to go to. I was able to give my first professional talk was at JPL in Pasadena, and later got into Caltech through those connections. So I kind of went the other direction from John. I started in space robotics, and I worked in the planetary robotics lab there at JPL when I was in school, on some early rover concepts that John's probably seen. And but then got really interested in the aircraft, and by the time I came to Pittsburgh, was going full tilt on helicopters and making them robotic.
Great. The other thing I had wanted to ask you about, Lyle, because I saw it on your website, and I thought as a kind of a near-term, very practical approach, a branch of your company, was the thing about inspections of the things like tank farms and so forth. Can you talk a little bit about that aspect of the business?
Sure. Yeah, so we have two business units at Near Earth. I've talked a lot about moving things, doing logistics. The other piece is a data-centric company. So there is value to be added in the world of inspecting assets, things like aircraft or tank farms, things where the value is very high, the cost to obtain the data can be high. The consequence of not having it is usually very expensive or could be catastrophic. So you can imagine, say, with an airliner, you need to do an inspection periodically, or if there's been hail or any other damage. But having a big airplane like that not flying is very, very, very expensive, right? Tens of thousands of dollars an hour for downtime. So with our technology, a smaller drone with a nice camera or other sensor can position itself very precisely and very repeatably with respect to other objects. Similar to what John had mentioned, a lot of times you don't have GPS, right? So how do you localize yourself within an area so that you don't hit anything and so you know where you are? It turns out that's a quintessential robotics problem. It's one of the first things you start to learn as a roboticist is how to tell the robot where it is. How does it figure that out? So it's one of those core technologies that enables us to address a market like inspection. Mm-hmm. Or landing on the moon. It all kind of comes from the same place.
Right. You kind of in a practical way, you've both dealt with some of the technical challenges you face, or you've talked about the applications of those. But I guess a broader question would be, what are some of the main technological or scientific challenges you've had to tackle in order for your products, your vehicles to do what they do? John, what would you say?
Well, some of the biggest challenges of flying spacecraft in space is that you really only get one chance at the hardware. If you're building a car or building even a plane, you can build test versions of them and fly them and test them. But once you send something up to space, that's it. It's not coming back. You can't go service it. You can't go do maintenance on it. You can't go and hit the reset button. So that's one of the single biggest challenges. So how do you build something that doesn't actually operate here on Earth? Because if you had a fully fueled lunar lander sitting here on Earth and you lit the engines up, it wouldn't take off. And that's because it's designed for lunar gravity. which is 1/6 of Earth gravity. So you literally can't do a full end-to-end test here on Earth of the entire system. So you have to do it in simulation and in hardware in the loop testing. So you get big racks of things that are going to simulate all the sensor inputs and simulate what the engines are doing. And really, the first time you're learning to fly the spacecraft is right after you launch it. You fire the engines and see what happens, and hopefully it lines up with your model. So it's really, really challenging. And then there's the environment. So you are flying through space, which is super hot if you're facing the sun, and super cold if you're facing the blackness of space. So it's like being on a baking sheet if you're facing the sun, and also a cryo chamber on the other side. So it represents really challenging thermal variance across the spacecraft. And then you've got radiation that comes from the sun. And anything as simple as even a solar flare or increased solar activity can send out a higher dose of radiation that could really mess up your spacecraft. So weird things happen to it. Like you can get what's called a bit flip, where suddenly the equivalent of a computer here on Earth is you get a blue screen of death on your spacecraft, and that could be a bad day. So you have to be able to reset your spacecraft. And then once you land on, well, once you get out to the surface of the moon, you have to do your entire descent autonomously. So you're 250,000 kilometers from Earth, and you are turning your spacecraft on and hoping that it can land on the surface autonomously, because it's really hard to communicate in real time from the moon. There's about a 6-second round trip delay for 3 seconds for physics, and 6 to 10 seconds if you add the ground network delays, and could be even up to 30 seconds. So it's really not practical to control the spacecraft on its way down. You are flipping a button and hoping it works the whole way down. And then once you land on the surface, it's really hard too, because now you're landed on a baking sheet, because the surface of the moon is about 120 degrees Celsius, or about 250 degrees Fahrenheit. And you have the sun baking down on you from overhead. And your job is to stay cool. So that's why a lot of spacecraft will have that gold foil looking thing on the spacecraft. Those are thermal blankets to radiate and deflect heat outward and keep yourself cool on the inside. And then we usually use a big white radiator to point to the blackness of space, and that's what we use to dump heat out. So I'd say the hardest technical challenges are overcoming the environment and overcoming you only get one chance to make it work right.
And that's a great summary. And of course, no matter how many simulations you do and how much preparation you do, I imagine there's also psychologically, for everybody who works for you, this idea that it could all go south in the middle of the mission. How do you deal with that? Do you talk about that inside the company?
Well, we do regular trainings for our mission control. So we will simulate the mission top to bottom numerous times before the mission goes. So the team is prepared. So if there's an anomaly, the team is ready to look into the hardware, the software, to try to figure out what's going on and try to troubleshoot it. But at the end of the day, we're all human. We're all sitting on the edge of our seats. We're all fingers crossed, hoping it works. It's space is a totally unforgiving environment, and there's really any little bit can go wrong.
Yeah. Lyle, how about you in terms of technical challenges you've had to tackle and overcome?
I think we're facing one of the biggest right now, as opposed to what John's group is doing, which is very exciting. And you always show the SpaceX employees cheering as their rocket goes up, and they hope it doesn't explode, and then it's like they're even happier, right? When our systems work, we hope that it's very boring. So what does that mean? Well, we're solving similar problems. Again, the core technologies, as we've mentioned, are do very similar things: landing, localization, making decisions by itself. And the thing that we face is we are in a continuously changing environment with many vehicles that are going to be out there operating every single day, with people who might not be super experts in our technology. We won't have a room full of engineers monitoring for the bit flips or the other issues, right? So on one side, it's a lot easier to design for, but on the other, it has to work day in and day out and become an industry, right? So how are we going to deal with thousands of these systems out there in a way where we can say something about their level of safety? And so the industry has a name for this, it's safety assurance. And it has had to grow. And one of the things we're doing as a company is helping define what it actually means for a robotic system to have a safety assurance. In the world of aerospace, there are certification standards, and there's different levels, design assurance levels, and given the level of safety or assurance you need for a certain subsystem, there are prescriptive things that you follow in order to certify that the thing is what you said it is. And I'm sure, Astrobotic is doing a lot of that with, especially it has to work the first time, right? So how do you do that? You can go through certification processes that are well established in aerospace. It's not easy, but there is a way to do it. But where we start to look at autonomous systems, standard certification processes don't apply anymore. Things are changing. You can't test to every situation. If you're going to the moon, I'm going to the moon, and I'm going to be in between the Earth and the moon here, and I'm going to be launching here. That's not changing unless there's some aliens up there messing with us and building things and changing the surface. You kind of know the environment that you're designing to, but a self-driving car or a self-flying vehicle is in a very complicated world. Things are likely to change. Things might start to break down. If the motor's going bad, how does it know? And so what we're working on are a set of standards in the community where you do make a safety case up front, and you do design with standards and certification where you can, but then you monitor the entire fleet over time, and the fleet itself collects data on itself and continues to make this safety case, right? So the people that are really going to determine this, the FAA is instructed to keep us safe, and at the end of the day, insurance companies are going to require something, right? And that, I think, is kind of the biggest hurdle we face, is given these very useful machines that are starting to become possible, how can we make a safety case and maintain and operate these over a long period of time?
I guess my psychological question for your company is, I think there was some talk early on about, how would the public, including businesses, accept the idea of drone delivery and automated delivery. But it seems to me as though people have adapted to that fairly well. What's your own experience been in that area?
In terms of?
Well, in terms of people trusting this kind of technology, thinking of it as useful rather than some kind of threat, things of that nature.
Yeah, I could talk about what we've seen on the military side.
Mm-hmm.
So we've been doing a program looking at what they call Unmanned Logistics Support Aerial, ULSA, and they have a smaller scale application, which is a vehicle. It's about 6 feet long. It can carry 150 pounds, about 10 miles out and back. And they're very excited about it because what happens is it doesn't compete with aviation. So what happens today is what they call a dismount, a soldier or a Marine carries between 100 and 160 pounds of gear into combat. And that will last them about 2 days. So not only are they literally weighed down by what they're carrying, but there's also susceptible to stress fractures and other issues. And then if they do want to be resupplied, that means a Black Hawk has to come, and a Black Hawk comes with two attack helicopters as escort, right? So now you have 3 very expensive, large things with their crews and the entire aviation thing behind it. Okay, so they basically just don't do it, right? So what they want is this thing they call organic, where the platoon level, they would have this thing on the back of a truck, and your dismounted soldiers or Marines can be downrange 10 miles, maybe carrying 40 pounds, and they can get continuous resupply with these drones. They just say, we're here, please come and give us this stuff. And then they don't have to worry about it, right? It just shows up and won't hit the trees and avoids, it doesn't need GPS, it can do all of the things necessary, and it just drops off the delivery and heads back and lands back on its truck.
Right.
So it's enabling a new thing, and they love it. Especially, we have our 20-year-old war fighters, and they grew up playing Call of Duty, and there's drones in it. They've actually used them in the computer games. They're getting the drops from the drones in the games, and then of course this should exist in real life. They're not even surprised, right?
Right. That's great. That's great. I want to switch over to a couple of other people who are online here. Deb Stein, I think you had a question. Can you unmute yourself and ask your question?
Yeah. Hi.
Hi.
Yeah. So I work at the engineering and public policy interface, and so I like for you to discuss more of the interface of public policy with autonomous vehicles. Like right now, you can't drive across the United States in an autonomous vehicle because some states say you can't use one. What do you see as sort of the chief barriers to autonomous vehicles generally?
Lyle, I think that's maybe aimed a little more at your company's mission. Can you talk about that?
Yeah, it's a moving target. And I think, the biggest policy is going to be from the FAA. They're the first and last word on anything that flies in the national airspace. So we have a very close relationship with them through a couple avenues, and one of them is through NASA. NASA Ames is out on the West Coast, is tasked by the FAA with working out what these safety cases mean and what it would mean to fly legally with an autonomous aircraft in our airspace. And then the rest is kind of up for grabs. But one of the value adds that Near Earth gives to the industry is the whole point of autonomy is to make these things safer. It's supposed to be part of the safety case or the use case that you're more likely to be able to do these things legally because the autonomy is there to deal with contingencies that you normally wouldn't be able to deal with, right? So that's kind of why we exist, actually, is flying robots are cool. But we don't build a company with 90 people because it's awesome. We did that at Carnegie Mellon, right? We built just because they're cool. But here, the value add, the things that our customers and our partners see is they have to make a safety case, and it's not just the FAA; it's global, right? There's the equivalent of the FAA in pretty much any country. How do you make your safety case that your operation that you're going to be using to make money will be okayed by the people that decide?
Right. It also strikes me in some ways, maybe I'm wrong about this, but it strikes me that maybe with flying robots, you actually have a simpler task in that regard than for ground-based robots in terms of the regulation of them.
Yes and no. I think legally, yeah, it's a little bit easy because it's one federal organization,
Yeah.
right? There have been pushes to decentralize it. in the last administration, I think, but I don't know how far that will go. There's a lot of inertia. But yeah, that's good and bad, right? There's one place you have to convince, but that's the place you got to convince.
I got you. I got you. It's a kind of a zero-sum game. John, did you have some thoughts on this too? I mean, I know it doesn't directly impact you quite as much, but
Yeah, it doesn't have as direct impact, but probably the closest that comes to it is the approvals that are required to fly to space. So we still need FAA approval to fly to space. We have to submit a full detailed list of every payload that flies with us and everything that's on the spacecraft. And that goes to all the cognizant authorities in our government to ensure that what we're doing is in line with national interests and make sure that it's not going to be an issue. So that's a very important part. And we also need FCC approval as well, because we are sending radio signals back home to Earth. So big, significant steps in the life cycle of a spacecraft that are increasingly important with the increased prevalence of commercial spacecraft, especially those that are doing the large constellations of spacecraft like SpaceX with their Starlink network, as well as OneWeb and others who are going to have thousands and thousands of satellites connecting us to the internet. So
right.
a new paradigm that's coming in space.
Very interesting. Arvind, I think you had a question, if you're still online.
Yeah, I have a couple of questions. One is for John. Is it possible that there'll be a point in the future where space would get too crowded, and that we can't? There will be a premium for launching new satellites or objects. Well, I'll let you answer that first.
Yeah, so we are seeing the beginnings of that now. There's increasing conversation and increasing concern around space junk. So if you look at the International Space Station, for example, there are numerous times in, say, a year, maybe a handful, I'd say 1, 2, maybe 3 times a year, that they have to move the International Space Station to avoid debris. There's also times that it's too small and they can't see it. So if you Google International Space Station hole in the solar panel, there's a hole in the solar panel at the International Space Station from some debris. So it is increasingly a problem. I don't think it's at the emergency stage, but I think what's going on with the space industry is a recognition of that debris issue, and that now there are regulations that prevent spacecraft from separating and leaving space junk. So for example, when you're separating your spacecraft a long time ago, they used to drop bolts off and other things that would fall away from the spacecraft. You're not allowed to do that anymore. And then there was a time, for example, when some of the large nations around Earth were testing anti-satellite weapons, and they would go blow up a satellite in space, and that creates a ton of debris, and that's a big problem. So that's not really allowed anymore. So I think it's something we have to manage and be careful of, but I don't think that we're in an emergency category. But it is also dependent on what orbit you're in. There are some orbits, the geostationary orbits, out in the geostationary belt, i.e. the part of the orbit belt that keeps the satellite directly over the same part of the land all year round. That's how DirecTV works and a lot of the satellite radio stations work. Those areas are getting a little bit more congested, and there's only a few slots because of the way the physics work. But space is big, and it's much bigger than Earth.
Cool. The other question would be for both of you. I think you both talk a little bit about like how you got inspired. Is there a barrier to entry for younger kids wanting to get involved, but they don't necessarily have the resources to get involved? Has that caused an issue with diversity in the field, and how's the field addressing both industry and academia wise?
I think it's a great question. It's something that aerospace needs to improve on. Aerospace is not typically very diverse, and it needs to be. It's got some work to do there. So one of our big goals at Astrobotic is to make space accessible to the world, and we've taken that the next step to actually create a nonprofit and build and announce the creation of the Moonshot Museum. So the company is gifting part of our headquarters for this museum, and the separate nonprofit Moonshot Museum is going to promote space and show and give a window to the experience of the thrill of spaceflight for our entire region. So that's our neighborhood and the whole region can come down to the Moonshot Museum, see real spacecraft being built that will fly to the surface of the moon through a giant window looking into our clean room, and then have a cool space experience right here on the north side. And to get to your question, I think that's an important piece of it. It's access to these high-tech industries and being able to have touch points to it, and having a kid walk up to the glass and imagine that they could be the one building the spacecraft on the other side. That inspiration is very key in development to put people on that path of tech development. And also another important thing for the Moonshot is to show that you don't have to be highly technical to get into space. There's business people, there's people that do graphics, there's marketers, there's space lawyers, like my wife is a space lawyer. So there are lots of different roles you can have in space, and you don't have to have the PhD from the high-end university or whatever. That is a myth and a misnomer that we are looking to dispel. And Moonshot Museum is one way that we can start to reduce the barriers to entry to get into space and show the thrill and the excitement for our neighborhood and our region.
Lyle?
Really cool.
Yeah, so many things have changed beyond the experience I've had growing up. I would have my mom drop me off at a university library 2 hours from the house, where I would discover books on robotics and stuff that I could then order. And I was really lucky to have supportive people in my farming town. You know, I loaded hay and things like that to get the money to build my gadgets. I think that's changed. And if you get on YouTube, you can find somebody doing anything. And I've learned many skills myself just by watching YouTube lectures and people building gadgets and things like this. So I think the information is there. One area though that I worry about, or people do talk about, is getting into the network of people doing things, right? So I like to tell people, you know, you can learn anything you want online now rapidly. They even have Stanford classes and things like this live, and you can just log on and learn what you want, but you don't get the network of people. So why go to Caltech? Well, because my roommate works at JPL, and the guy down the street is working at actually one of my friends was employee 11 at SpaceX, and she went in, right? So I just know these people just because I was there, and it has opened up many things that I can do now because I know these people. And I think something like what John is mentioning, where yeah, they can go learn, they need to know these things, but having peers and understanding is important. And I think it's something that the aerospace industry, again, needs to do a better job of.
Thank you. Those are great answers. And let me wrap it up. We have about 5 minutes. I think I'm just going to ask you both a kind of a general question, which is, name 1 or 2 things that you're most excited about in the near future for next steps. You've got a lot of exciting things going on, but what's energizing you right now? Lyle, I'll start with you.
Really soon, next year, I think we will be on a commercial drone doing deliveries for money, and it won't just be a stunt. So we're gonna, I think, see the first real adoption of delivery drones running and hopefully turning a profit. This is beyond my expectations how fast this is happening. I'm really excited about that. And a near Earth system will be guiding that vehicle.
Can you say what part of the country that would happen in, or is it too early?
It actually wouldn't be in the United States.
Ah, okay, okay.
So that's about all I'll say. But if you look at our press releases, you can see all of the public information
Okay,
on our partnerships and who we're working with.
great. John?
Well, gotta say for next year, that's our first moon landing attempt. So that is going to be edge of the seat exciting for our whole region and the city here. If we can land on the surface of the moon successfully, it will be the nation's first landing on the moon since Apollo, nearly 50 years later. It would be the dawn of a new commercial age for flights to the surface of the moon, and the dawn of routine, regular access to the surface of the moon for our nation's scientists and developers. So it's that's the top priority, singular focus for Astrobotic right now, and that is the thing I'm most excited about, but also the most nervous about.
Sure.
Coming into this next year.
I also, down the road, would Astrobotic see itself being in the position of going beyond the moon, being involved with projects for other space missions?
We're keeping an eye on that, and we do think that that's a possibility for expansion. In particular, the other moons and airless bodies in our solar system. When you go to Mars, where there's an atmosphere, there's a lot of new, different tech that you need for that, between a hypersonic parachute and a system that can absorb the heat of impact as you're coming through the atmosphere. It's a whole different echelon of lander type. But for airless bodies and other moons, we're going to be very well positioned.
That's great. I think we've kind of reached the end of our time. I haven't got it, I haven't got the knack of TV producers to take it right down to the second, but we're at 12:59 right now, so I think we've done a pretty good job. Does anyone have a burning last-minute question they want to ask? I see nothing on the chat. I want to thank you so much for your participation. I think these areas are so exciting, and it's such a treat to be able to talk to people who are sort of at the front edge of technologies that are just developing in their respective areas. So thank you, John. Thank you, Lyle, very much. It was very informative and really interesting.
Thank you.
Thanks so much, Mark. Good to see you,
Okay.
Lyle.
I gotta go get a beer. It's been a long time.
Yeah.
That's our other job, is to connect people.